Hello everybody, it's Kevin here again, and this week we're going to cover a little bit more API integration with our Dart applications. So, if you remember from last week, we covered how to make API calls, how to send GET requests, how to send POST requests, and how to use a DO package, and it was pretty straightforward. So this week we're going to expand on that. So if we look here, we still have the same basic structure of the application. We'll actually reuse the old one. I believe in the old one I had the login button here in the center, not a big deal. The new functionality is really going to take over all of that. So if I get rid of that and I send a bad login, a bad password, it's going to be the same as before. But now if I say, alright, here's the correct password, and I try to log in, we have some cards now. So hopefully you're not thinking, oh boy, we're going to do update and deletes in this video, because we're not. This is just the basic structure that I threw in here just so that we could kind of demonstrate what's going on. But if you remember from the API, these are the current items that we have access to. So if we send the get users request, we have access to some of these items here. Now, it'll be a little tricky. It'll appear a little tricky. I know I say that all the time, but it really will be, because we have to come up with a solution now for storing the token. We have to use a service to store the data, and I shouldn't say we have to. Now, a lot of this is completely subjective. So let me pull up the project here. Open this up with Visual Studio Code. So the deal is that the way that I do certain things here in this class is the way that I do them is my way, right? So that's how I've written apps my whole life. These structures that I use are the structures that I have basically always been using. So the whole bearer token authentication, that's what I'm most used to that. With what else? The way that I present the data, that's what I'm used to. Using services to move data back and forth, and to use them as a structure to hold data. That's something that I've always done, at least in the professional development environments. Now, that doesn't mean that you can't do it your own way. That's totally acceptable. It's just realize that this is how I'm going to do it. This is what I'll provide support for, at least for the class. And I'm totally aware that there's other ways to do it. There's probably better ways to do it. There's definitely worse ways to do it, but this is the way that I'm going to do it, and that's that. So to get started though, why don't we start the application here to see where we are at, and we'll kind of go over what we need to do. We need to have a starting point at least. But while that gets started, we need to think about what we have to do. So if we think back to the old app, we displayed the token. So we had the token available, but now we have to store the token somehow. And we have a couple options, right? We can use local storage, we can use secure storage, we can use a global variable that can be referenced throughout the entire application. Now what I'm going to be doing is I'm going to be using secure storage, and the reason is because it corresponds with structures in both iOS and Android. So if you compile this application, if you're writing your own app, and you write it for an iOS platform, you can use local storage, and it'll access, I believe, the keychain. And actually, why don't we pull up the exact documentation here? So do secure storage, pulling it up in another page here. Bear with me, please. So this is the documentation for secure storage. If we look here, basically, keychain is used for iOS. AES encryption is used for Android. The beautiful thing about newer high-level programming languages such as Dart, and frameworks more than anything, such as Flutter, is that all of these structures, all of these low-level structures, relatively speaking, they're kind of hidden away with essentially what's an API. Now it's not an actual. I guess it depends on what you define as an API, right? This is just a library essentially that we're calling, and we're going to reference it. We're going to use some of the members that are inside of that library, such as we're not actually going to use delete yet, but we're going to use read, and we're going to use write. So it's pretty nice because we can kind of offload some of that off to this here. If we wanted to write our own implementation, say we were writing an application for an application in Objective-C for iOS, or even in Java for Android, or Kotlin, or whatever you want to use for Android development. There are libraries out there, but you could also write your own implementation, and that takes time, and it takes a lot of time. So that's the beauty with these frameworks. Now, of course, that kind of comes with the caveat where if you don't know exactly what this library is doing, or this package, it can be problematic, because if there's a security issue or maybe something wasn't implemented properly, that can obviously be problematic. Because at the end of the day, if you think about open source, anybody can contribute, right? So that's this. Now, don't take this right away as like, oh, I'm knocking on open source. Open source is awesome. Just realize that if somebody creates a package, and this package, say, was written by some random guy in college, right? It's totally fine if the package works and all. But if they're not maintaining it, if they're not actively maintaining it, and there's no other available package for what you're looking for, and you just go ahead and use that package, that can, raise some red flags in a production environment. So just keep those things in mind. You gotta do a little bit of research. Dart's pretty good with having good packages and reliable stuff, but just one thing to keep in mind. So we are going to be using, like I said, the secure storage package, and that's going to be used to store the token. We can also use it for other items later on in the application, like passwords and anything else. So I'm going to set up the whole framework so that we can add stuff easily rather than just referencing that package each time. And that's going to be known as the data service, at least in this application. That's what I'm going to be calling it, and that's what we're going to be referencing it as. So that's that part of it, the token storage and the token use. Why am I making such a big deal out of the token? The problem is that if you have a token that is easily available, and this can vary by what you do, right? So if you use like an auth type implementation, it can be a little bit different. It also depends on your JSON Web Token implementation, because you can store some stuff in JSON Web Token. So like if I go on to a JWT encoder, I go on here, see if I can find. Okay, so here's a JSON Web Token, for example, right here. Notice how we can store some stuff in there. We can store an issue date. We can store some data, right? So this payload here, and we can store some other information here. So if I start changing this up, the token itself is going to change. We can also change the header, and we can use different algorithms for encryption and different types for the token. So the deal here is that if somebody has access to this and you have a token that doesn't store a whole bunch of stuff, like for example permissions. So if you have an API, for example here, let's pull up this one right here, the one that I wrote. We have this API here, and say this API has user access type logic, where if you pass in a token and that token has say like author admin type access, and another one has just permissions basically. So a token with a certain permission can access this route, but not these other ones. What can happen is with a pretty simple implementation like the one that I have here, the bearer token implementation, there is no permissions. There's no user access delegation, right? So what that means is that if you have, say you have some resource, right? So you're a user, your username is USR, right? Just for this example, your username is USR, and you're trying to access your stuff in the server. So what you might do is you might send your token right to the server here, and you're gonna go into this route, and we're gonna check to see if your token is valid. If it is, then we're gonna start moving forward with the logic. If it's not, we're gonna send a 401, and we're gonna say, hey, there's a problem with the authorization. What can happen though is if you have a token, and if you intercept it somehow via like a man-in-the-middle attack, or say you're writing a web application and you're storing the token in plain text, or you're not flushing it out after the session's done, what can happen is you can use that token and you can pass in something else, so like a different username, and that resource can be returned. So this is common. This kind of stuff happens out in industry. So you got to take care of this token, because this token essentially is your key to access to accessing all this data here that's available in the database. for this API. So this, again, this does happen. It is widespread. So protect yourself against it. Protect your applications against it. It's kind of like the whole salting and hashing type deal, where you don't want to store your passwords in plain text, and there's a whole bunch of reasons behind that, but you just don't want to. So it's the same deal here. You want to secure your tokens. But now that that rant is over, let's get back to writing our application and actually kind of demoing and going through what functionality we're going to need to add. So we have that token, we're going to use it, we're going to have a data service to store that token securely. We are going to have another page to display the stuff on screen, so all the users in this case, and see if I can think of anything else as of right now. That's about it. We're going to have some nice cards that we're going to use, and those are going to come from here, this card library. Actually, I copy pasted most of this card library code kind of to show how easy it is to take the documentation's examples and just form them around your use case. So what we're going to do here is, let's kind of move forward with the demonstration here. Just a test password. Try to log in. It's not going to work. It's a login failure. If we try to send in a good password, we get a token back. So first off, right off the bat, we're not going to want to show this token anymore. So let's get rid of that right away. Let's see here. Get rid of this. You just return in there, not do anything. Actually, I suppose we do have to, actually, let me think here. Send the request. Alright, not going to return, because if we return early, we're never going to set the state and set the loading to false so that we can get rid of that. So let's just kind of leave it at that, and we'll set a comment here. Just to let our formatter kind of keep everything nice and clean so that we can access that later. So we have the token at this point. So what do we do with the token? Well, we have two options. We can display the we can store the token from the UI, or we can store it at that the API level inside of the client. So that's actually what I'm going to do instead. But to do that, we're going to want the data service. So what I'm going to do is inside of this repositories directory, I'm going to create a new file. I'm going to call it data service. Whoops, and probably would help to give it an extension or a file name, file type. And it's going to be pretty straightforward. It's just going to be a class named data service. Now, we need to add a package in order to actually get anything done here with the data service. So in order to do that, we're going to stop the application, and we're going to add the package. Now let me look back at the documentation to see what the package name is. Flutter Secure Storage. So let's just do flutter pub add Flutter Secure Storage. Just some snake case there. Alright, that's been added. If we look at our pubspec.yaml, we should see, okay, there it is. Flutter Secure Storage. Pretty useful. Kind of like our npm install, or like our, what is it in C#, the NuGet package manager. Pretty straightforward. Just do your flutter pub add. And again, in case you missed it last video, you can always go to the installing portion here, installing tab, and just use this command. So now that that's added, we are going to go back to the data service, and we're going to add some stuff here. So first, we're going to want to reference that library that we're going to be using for secure storage. So we're going to import. We have two options, right? I know I say that a lot, but it's because we do. So we have two options. We can import it directly. We can import it directly this way, or we can start referencing it. It's either or, right? The reference has to show up eventually. When I say referencing it, I mean trying to instantiate Flutter Secure Storage. So I'll just add it manually this way. There we go. Now inside of this class, we are going to want an instance of Flutter Secure Storage. I'm going to call it Secure Storage. I'm going to break a little bit of the naming rules here, so I'm going to use a capital S here. It's going to give us a little, it says right there, right? So it doesn't follow their identifier policy. That's fine because the app's still going to work fine. Totally depends on your organization and what the coding standards are there, if there are any. It's good to have coding standards though, kind of keep stuff clean. My standard is this property that I'm going to be referencing. I'm just going to keep it capital there. So I'm going to set it as constant, and I'm going to create the instance. Perfect. Now we're going to get a little bit into documentation here, writing your own documentation. So let's start off with function add item. So I'm going to create function add item, which returns what would be equivalent to a task. In this case, it's going to be a future, so future type bool. All this is saying is that there's going to be some sort of asynchronous action that's going to take some time, so we can't just return a primitive directly or any type directly. It has to be wrapped around in this future. So I'm going to call this add item. It's going to take in a string, string key and a string value. It's going to be asynchronous. We're going to try to do some stuff. Catch the error. Print the error. And return false. So if we look into the documentation with Flutter Secure Storage, we will see that it's asynchronous. So that Flutter Secure Storage, trying to read from it, is an asynchronous action. So notice here how they do await storage.delete key. Of course, storage is the instance of Flutter Secure Storage, or the identifier for the instance. So we need to handle that. That's why it's asynchronous. And what we're gonna do here, you'll start to see as I start writing the logic. The first thing I'm going to do is I'm going to check to see if the item exists. You don't have to do it. I'm sure that it handles it automatically, but this is just something right, so that I don't have to offload that onto its own logic. It might do it under the hood, it might not. Not entirely sure. Could read the documentation to determine whether or not it actually does it, but in this case, I'm just going to check to see if the item exists, if the key exists in secure storage already, and if it does, we're not going to add anything, and if it doesn't, then we're going to add it. So if the key is null, so notice here if we look at read, it returns a nullable string. So it decrypts it and returns the value, and it'll return null if the key's not in storage. So if it's not in storage, we want to add it. So we're going to say await secure storage dot write. The key is the key that we pass in here. The value is the value that we pass in again. This here, it might be a little bit controversial, where I have in this case the argument is the same. It has the same name as the identifier that we want to pass in. I guess probably the technical jargon here would be like the parameter has the same name as the argument, but it'll compile. It'll work fine. Just it's something to keep in mind. So once we add that, we are going to return true. We're going to assume that it looks good, because it looks like it's void, but we're just going to assume that if it gets this far and if it doesn't break, it will return true right there because it must have added. And if not, so if it is in secure storage, we just want to return false because we can't add it. Excellent. Now let's hover over add item. Notice how add item doesn't give you any I'm going to actually look at the time here quick. Okay, perfect. Notice how add item doesn't give you any details. It's something that you've defined. So what we can do is we can add a little bit of documentation. Three forward slashes, and we can say, we can give it a small description. So stores a string in local storage or in secure storage. Save that. If we hover over it, notice stores a string in secure storage. If we reference this later on in the application, that can be a little bit, not a little bit, but it can be quite useful, especially if it's a huge class that you've written that has a whole bunch of functions that do a whole bunch of different stuff. So now that we have that created, we can reference this. So let's go back to my main.dart. Let's see where we are. We have, once the login is completed, we fire off this logic, do a set state. So we are going to want some more logic here. So the first block of logic we're going to want is the block of logic that will be executed when we want to make the API call. So right after the login, because we can't make that API call without the token. And actually, I'm kind of getting ahead of myself, aren't I? Because if we think here, we are going to need that bearer token. So what I'm going to do here is getting everything synchronized here on both screens. What I'm going to do here is I'm going to get rid of some of the logging that I have here, because this is not, actually this one might be kind of necessary. So we have access to the auth response, which is an instance of auth response. We are going to want to import the data service because we're going to be reading and writing to secure storage. So we're going to import that. So now that we have that imported, we are going to want an instance of that. So we're going to say okay, so this is going to be, notice how I did the capital here, over here. Should I continue with that, or should I follow convention that I have here? I'll just follow convention that I have here because it'll be private. We don't want any other member accessing data service outside of user client. So we're going to name this data service. Now that we have that instance created that we can access, we're going to do a little bit of checking here. So first thing we're going to do is we're going to check to see if the token's not null. So if the response token isn't null, we'll go ahead and store that in our data service. So I'm going to say await. Notice that it's already asynchronous, so we can do some asynchronous stuff here. Await add item, and the key is going to be token. The value is going to be access auth response.token. So that's going to be stored in local storage, or in secure storage, I'm sorry. And we will return the auth response. We're not necessarily going to use it, but we'll return it in case at some point in the application we want to, at some point later on in the application lifecycle, we want to reference it. So that's good so far. We have stored it in local storage. Now let's kind of get this block down. Let's add the API call for fetching users. So what we can do here is we can create another function to get our users here. So just gonna say future. It's gonna return a list of type user. It'll be a nullable list of user. Whoops. And we have to add our reference to user here. Whoops. Oh, whoops. I don't have user defined yet, of course. So let me pull it up on the other screen just so that I can get the parameters, or all of the, sorry, not parameters, all of the properties defined. So under models, we will create a new model. We'll call this user.dart. This will create a class user, a couple properties, string username, string password, string email. I'm going to keep going here. And then the constructor. Again, in case you haven't noticed, that corresponds with all of the properties of user that we return. I'm not going to use this. I believe it's versioning for Mongo. We're not going to reference that. It's not going to be relevant on the client side, so the application here. The ID, we're not quite yet. We can always add it in afterwards, but at this point we're not going to reference it. Actually, you know what? I might as well just future-proof this, because we will need it for updates and deletes later on, because that's how we're gonna find it. So string ID. Okay, perfect. On the fly changing of the mind. I hope it's not too inconvenient for everyone. So we can call this get users async because it's just an asynchronous get users call. And since it's just a get request with no query string parameters, we are not going to pass anything in. We don't need anything. We need to add the reference to user here. And again, we need to do our try catch. We'll return null if there's any problems. And in here, it's going to look quite similar to our post request, except instead of sending in data, we're going to send in some request headers, because that's how our authorization is set, at least with barrier token authentication. So what I'll do first is I will try to read the token. So variable token. We're going to try to fetch it from local storage, or I'm sorry, I keep saying local storage, from secure storage. Did I even add that yet? I did not add the get item logic yet. So let's add that here. What this will return is a string, a nullable string, because it might exist in local storage or it might not. I'll call it try get item. It'll take in a key. It'll be asynchronous. And we'll have some error handling. Perfect. We have our try get item implementation here. Add a little bit of documentation here. Perfect. Hover over that. That looks perfect. Now that we've handled that, we can try to get our item, which is our token. This is the key. So we need to check to see if the actually, one second. I need to look over one item here quick. Okay, it's just a minor detail on the implementation. It's not going to be a big deal here. If you're wondering it, I referenced this before rather than referencing the token, even though I defined the token above. So it's inconsequential. It's gonna be the same result, but in this case here, I'll just reference the token to make it a little bit more readable. So if the token's not null, we can send our request, and if it is null, we'll return null because the user's not authorized, or the token's not set. So yeah, the user's not authorized. So since the token's not null and the token does exist, we are going to try to send the API request. So what we can do here is we can just, again, just like here, in a variable response, we'll try to send a GET request. Notice how this corresponds with, let's see here, our get users route, and that corresponds with get users in here. Our route prefix we have set up here somewhere. There we go. So that's not going to be, it's not something that we have to worry about, at least in this class. So we're going to send a GET request to get users. Here's where it gets a little interesting. I'm going to add the semicolon there just to keep it clean. We need to add our headers. We need to start building our headers. So the way we can do that is we can use property options here. So if we hover over here, we can see that we have property options that we can pass in. So options, that'll take in an options object, or not an instance of options, which I believe is defined by DO. Yep, it's from DO. It's in our DO library. So options we can have headers set. So headers, and if you look at what that is, it's a map of type string comma dynamic, so string comma object. And if you think back to here, back to our requests, remember JSON is it's the language essentially that we communicate all of our REST calls in, including headers. So notice the way that this is formatted. It'll be formatted just like that. So see here our headers, create a new map here. Content type. You might be wondering where is this, right? What is content type? Let me define it here quick, in case you're not familiar with this portion of representational state transfer into HTTP more than anything, honestly, hypertext transfer protocol. If we look here and we look at the request that we sent via Postman, notice how the header defines an authorization token. Notice how we have a authorization header item and a key, and then we have the value of the bearer token in this exact format. It has to be in this format or else it's not going to work right. We don't define anything else here, and it'll probably work without it, but in this case we will anyways, just to be explicit. So our content type is what we, if you remember back to the REST and the whole API introduction lecture, it kind of goes back to that with headers. Accept, what we'll accept is application JSON, just like this. We don't want XML, we don't want anything else, we will just accept application JSON. Authorization, this is the most important part for making the request, for sending the request. If you run into any issues during the implementation here with authorization not working properly, keep in mind that if you misspell this, it's going to be problematic. These things are case sensitive. well, actually I'm not entirely sure if they're case sensitive, but they do have to be spelled correctly. So if you don't spell them correctly, that's going to be problematic. Remember how I said that we have to have bearer defined? Or we have to have bearer this way, this exact way, the way that it's written right here, or else it's not going to work right. And then in here we're just going to interpolate token. See if I'm forgetting anything, but it doesn't look like it. Next, what I'm going to do is we want to parse this response just like we did up here. We're going to do the exact same thing down here. We're going to say we're going to create a new list of users that we are eventually going to return. Going to name this list users. And here's where it can get a little tricky. You might stumble on this if you're working on your own implementation. So if we don't assign anything to list here, and then you try to assign something to it later on, it'll give you a problem. It'll give you a little error saying essentially that something has to be assigned to it initially. So for that initialization, we're just going to say it'll be equal to a new list, new empty list. Of course, this is going to compile. This will all work great, but then this will also lead to a problem when we try to add something to it because it won't be growable. So we can set the growable Boolean argument to true. All this says is that the list here can grow just like the way it sounds. It's growable. Next, we want to check to see if the response is null. So if the response now, depending on who you talk to, some people like to say that you want to handle this block essentially rather than handling the negation first. Handle the inverse, and that can lead to code that's a little bit more readable. We can handle it either ways, right? So we can handle it via the negation. So if the response isn't null, then do some stuff else, do some other stuff. I'm going to handle it this way. I understand, and I'm making all of you aware that this can be frowned upon with development, right, in a production development environment. However, it'll compile, right? So it'll still compile. It's just one of those code guidelines that some people have. So if the response is not null, we're going to loop through the response data. We know that we're going to be expecting users, so we're going to name it appropriately. And why can't I access data? Okay, let me look at this real quick. Again, just like last video, error message ID I0T, idiot error. We need to await this. I'm surprised it didn't throw an error before. It really should have. I suppose since it's assigned to a variable response, it just sets that variable to the future, right? The future instance, that the future response of type T. So that's why it didn't throw any errors. So if we would have said response type dynamic response, which is I believe what that returns. So if we don't do that, it's going to say, hey, there's a problem because we can't assign the future, right? This task essentially to the non-task, right? So we need to await it. But since we didn't do that, we just used variable. It worked just fine. So keep that in mind. This variable, this var keyword can be useful. It can be a blessing and a curse. I mean, it depends on how you use it, right? So if you are creating, if it's pretty clear that you're creating an instance, so I could have done this, right? So I could have done var users is equal to new list.empty. That might actually be problematic since I don't define what's going to go inside of this list. It might not, but if it's like a primitive that you're trying to access, you don't have to define it explicitly, or like if you're just trying to create an instance of users and you say var users is equal to new user, that'll work just fine, and it's pretty obvious that it's being assigned and it's the type as user, but the type isn't resolved until runtime. So let's kind of move past that. I know I keep going off on tangents, but it's important to be aware of all of these items when you're writing logic. So we're going to try to add something to here and a user, instance of user, because again this is a list of users, so we're going to add a new user. And we will be accessing properties of user, right? Each one of these response. So let's look back at the data that we get back. So this entire response payload is the it's the whole response. If we look at response.data, it's that map of all of these items. And then if we think into this for loop here, each item in data is one of these. That's how they correspond. So just keep that in mind. That's what I'm doing here. We can break through it, so I can kind of demonstrate how we're moving through it, how the data is flowing through. But just so you're aware, that's how that works. And since I should have really covered it back here again when I had it pulled up last, but it'll correspond here. So username, password, email, auth level, they need to be written the exact same way. So whatever it'll expect, that's how it needs to be set here. I am aware that you can create a from JSON implementation. So if we go into our class here that we're creating instances of, if I look up from JSON Dart, we can pass in JSON, and it's the serialization / deserialization, that whole deal. Basically, this is the deserialization into a type. So from this JSON, we'll deserialize it into a type person in this instance, in this case, right? So that's an option. We can do it that way. It's probably a little bit cleaner. Be aware that that is a way that it can be handled. I don't want to handle it that way. I want to handle it this way, and this is the way that I'm going to handle it. So this is what you all will see, but be aware that that is a way to handle it. So user, if we look at what user takes in, it takes an ID. Whoops. So we also need to pass in the ID, which is just underscore ID. So what does it take in next? It takes in a username. So user position username. Then it takes an email, I believe. No, a password, and then an email. I believe that's what it is. Auth level. Yep. Looks good. Okay. There we go. So now that we have our list of users filled, we want to return our list of users. So that's perfect right there. So we have our getUsersAsync function, method function, whatever, written here. So now we need to invoke it now. We need to call it. We need to send this API call. And if we remember when we have to send this API call, we have to send the API call after the login is successful. So let's go back to our login function. We need a function, getUsers. This function won't take anything, it'll just be invoked. It's essentially a granularization of our blocks of data, instead of our blocks of code. Instead of having a bunch of code just a huge block here. We can have functions that we can call later on. So if we want to get users in another area in here, we can just call the get users function, of course. So instead of this get users function, we want to set state. The reason we want to set state is because we want to start loading. We want to let the user know that we're loading. Then we want to send the request. Get users async won't take anything in because, again, it's a get request. That doesn't take in any query string parameters. Oops. There we go. Once we get the response, that's pretty nice right there how I just tabbed. Handled that for me. We can say response. And now we want to have another function to handle that. So I'll name this function get user success. Now if we remember what this response is, it's a list of type user, a nullable list of type user, so that's what we're going to pass in here. We have to add our reference. Excellent, it's all coming together quite nicely so far. So we need to set state again. If you remember from the last video, as you jump between different blocks of code, you need to set state as the state changes. So it's fine to set state multiple times. I'm sure if you're setting state within a for loop or anything like that, that can probably be super problematic. So something to keep in mind. Look at the time here. Okay, perfect. So in here, we want to check to see if the users are null. And if they're not, we want to, let's just display our users. Just display the username for each user. And have we invoked it? We have not, so we need to invoke that function. Call, invoke, either or, same but different. Let's see here. Okay, and since we don't need to do anything with our auth response, we can just call it. I guess in this case we could probably just get rid of this code because it's not necessary, because the response is not null. So let's go ahead and start debugging here. Oh, whoops. I think it's loading. There it is down there. I'll be right back when it's running. Okay, so here we are. Let's try to log in here. I'm gonna send in a bad password, see what it does. Excellent. Good password. We did some stuff. We didn't see what exactly we did. Let's try that again. Looks like we did not display our users. So we need to determine why this is not working right. Okay. Oh, we don't do anything with the response, of course. It's pretty obvious. And I stopped it. It's beautiful. So what we want to do here is we want to call function on get user success. And this should be a little bit cleaner now. be right back when it, okay, or not. It'll start right up just fine. So let's try to log in right away. And see if we have anything here. Okay, that's good. Whoops. Perfect. So we have 2 admins and 1 test. Let's see if that's correct. Admin, admin, test. Perfect. So that all looks good so far. We have our data coming into the client side, to the front end of the client side. So again, let's kind of look at what we are doing here so far. If we go into our get users async function, we can check here to see what it's doing at each step. So we sent our login request right after that happened, and actually I will move a couple steps back. Let's start off here. So everything happened, everything was perfect. We sent our login request, we got the token back, and it wasn't null, so we added it to local storage. So let's step into there and see what it's doing. Here is our add item function in local storage, in our secure storage class that we wrote. And I'm curious as to why it returned false. Let's try that again. Okay, oh, because it already exists in memory, that's right. So we tried writing the token out to the secure storage, but it already exists, so we'll return false. That's perfect. And we try to read it. Why are we in here? This is one part that can be a little, it might be due to the set state. Okay, there we go. So we are out of that. That can be a little bit finicky with the debugger, so if that happens, just set a breakpoint right after, or to the next spot that you want to see of execution. So the response, we got to the get users. Actually, I'm sorry about that. We went too far ahead. So we were inside of here, right here, the login. So we stored that token. Right after we stored the token, we go to our on login call completed. So let's try that. Once we get into this function, we have a response with some stuff, with some good stuff, so we know it's a good response, so the response is not null. Then we go into our function get users, step into get users, and if we look, we set the state, set loading to true. We jumped right past that. We set a breakpoint in there. Okay, so now we are in the get users function. We set loading to true. We sent the API that request, the get users async request. Well, not quite yet. We will. So I'm going to F12 into this, and let's let it send that request. Continue. The request has been sent. If we look at the response, we have a 200 status code response, which means it's okay, just as the status message states. What else? Let's look at our data. We have 3 items that came back, and this looks beautiful. So far, so good. Now we need to parse all of the data. So if we go into this for loop, we will grab the response.data. Okay, so can do that sometimes during debugging inside of asynchronous functions. So let's just kind of just restart the debugging instance here. Sorry about that. It might do it again, it might not. let's just try it one more time, see if it works. Okay, that was our old breakpoint. So really quick before this breaks, let's step into this. Look at response.data. Okay, yeah, so that's not an option. We can't do that. Essentially, what happens at this point is we read response.data, we store that into user, which again is, or we take response.data, we take the first iteration of it, we throw that in a variable user, which will be one of these. Once that's done, we add to the users list a new instance of user here. A new user is probably the better term there. And we return the users right away. So let's go back. Start debugging again. Let's get to this point again. So at this point, we got our response of users. If we look at our locals, because what can happen sometimes, so yeah, in this case, for example, it might be because of the set state. So the execution, or the maybe all the way down to the level of the pointer, might be at a different spot than if we didn't have the set state here. So we can't view it directly here. It might be a bug, might not be, but we can see it here in our locals. Take advantage of that. So here is our list of our nullable list of users. Since the users are not null, we will loop through them and then we'll display the username. We'll print that to the console. That's exactly what we see down here. So far, so good. This is all looking pretty clean. So what we can do now is we can create a views directory. And we can create a users view. And of course, just like last time, I didn't give it file type. So it'd be a Dart file. And in this users view, let's see here, it'll be a stateful widget, so just STF tab. Call this users view. Escape out of that. And we need to add our own parameter in here. So actually, before I do that, I'll just create it. I'll name it in users, and that's because we will be referencing a different. We'll be referencing users again, but I just want to avoid any ambiguity because of that. So we want to add our reference here. Now we need to add it in the constructor. Whoops, not required in. I'm thinking way back to another programming language. There we go. Now we need to pass in our instance here. After that, we want to add our instance of users that we'll be referencing within the actual UI. So I'll just say late list. And if you remember back to week 5, I believe, that's where I covered this. So if you look back to the week 5 video, that's where I covered the interpage navigation and creating new views and pages. Widgets, I guess, is the appropriate term. Then we have to call this here. So far it should compile, all looks good. Let's start building the UI now that we're in here. I'll kind of start flying through it because, whoops, I lost my window there. Sorry if this is, it's kind of technical difficulties here. Okay, sorry about that, everyone. Okay, I'm gonna now so we're at about an hour, so I kind of want to start flying through this. So we will return a container. This container is going to have a child of scaffold because it'll be a new page. We'll take in an app bar, set all of our app bar stuff. Let our auto formatting do its magic. In the body, we will want a single child scroll view. The reason is because we don't, if we display more than the items that we can show on screen, then that's, we want to handle that. We don't want to have any UI pixel overloads or pixel out of bounds errors. So single child scroll view, and set the child to a column. Children of column. Let's just say just a text widget for now. Excellent. So now we need to navigate to this. If we go back to our main.dart, in our function getUserSuccess, instead of just printing the users, what we can do is we can pass them into the, we can push a new route modally. We can push a new page modally, so, oops. Lowercase. Pass in the context. Let's add the reference here to semicolon and a reference. Takes in users. As you can tell right there. And a nullable key, so we're just not going to pass the key in because it's not necessary. At least for pushing the route. Perfect. So in theory here, if we hit the login button, we should move to the new page, and we do. Here we go, view users. So that functionality is pretty good so far. Let's go back to our users view. Here's where it'll get kind of interesting. Let's go back to this kind of to show how I used it. All I did is I just copied this card. So here is the card that we had before we were displaying, or that we saw online in the documentation. So we can just work with this. So now that you see it here, I'll create the iterable structure because I don't want to work around this and refactor it. So just get rid of that. But just so you know, a lot of it's just copy paste like that, and then you can modify stuff as you go. So since we have a column here, it can take in children, we can also do a neat little trick here, which is to map our users. And then we need to list here. Okay, let me look over that really quick, just to save time. Okay, so one thing I don't really like about Flutter very much is how sometimes it'll give you all of these obscure-ish errors, like argument type list of type null can't be assigned to parameter list of widget. And I mean, yeah, I guess if you sit down and think about it, that is true. But really, I mean, it's just syntax. That's all it is. So just had to return something. So here we go, flying through it back and forth. Let's continue with the implementation though. I did make a few changes, like I said, just to have it suit our use case. One of them was adding a little bit of padding around each item. So we'll add some padding. Have it be 3 pixels all around. Oops. And then we have to have a child there. We'll have a card. That's the structure that I used. That's all I looked up, by the way, I just looked up card, essentially. If you look back. Flutter card. That's all I looked up. Pulled up the documentation immediately. This card will take in a child. This child will be a column. It's because we want an iterable. Or not an iterable, I'm sorry. We want several things in there displayed using that nice structure that column provides. So main axis size. Now, since I didn't write this logic myself, I just grabbed it from the docs. I'm not entirely, I don't always use all of these properties, but be aware that they exist and they were using the documentation. So this is one change I made. Rather than having whatever icon was displayed before, I have a person, essentially, to kind of show the user that it's a user that they're looking at, a person, someone that's being represented. Then we want a title. And once we get this title written, let's look at what it looks like so far. Save that, log in, and there we go. That's how that looks so far. We have our user icon, and we have some data here, some information. Next, we want to display the subtitle. I can't stress it enough how useful this is, by the way, the save and automatically having all of the changes and logic update on screen. So if you work with Maui, for example, since the UI is handled via XAML, so it's essentially its own version of, like, it's a markup language. It's not its own, it's not proprietary or anything, but it's what Maui uses. It's also what WPF, so that's Windows Presentation Foundation, I believe that's what that uses. Xamarin, so the whole Microsoft ecosystem, that's what all of that use. That's what all those use. And the thing is that while they do have UI hot reload, which is kind of like our hot reload here, which I think, well, just via the save, every time we save we do a hot reload. Then here this would be a restart. While they do have that for the UI, they don't have it for the logic, at least not to the same extent as this. So for example, here we can go and add a new API call and add a whole bunch of parsing logic and all that, and more often than not it's going to work just fine. You're just going to have to save, and then right after that you can go and make that API call from the UI side, and it'll compile. It'll do that just-in-time compilation, and it'll work just fine. So that's a huge advantage of Flutter over that, the whole Microsoft ecosystem. Again, you do have to pick and choose though. You don't get the same level of native interaction as you do with Maui and Xamarin. And what I mean by that is, while you do have structures, so while there are structures to get from the camera, so like Flutter, I know I'm going off on a tangent, but it's valuable information. So while there are packages like the camera package that we can access and we can use, it's not accessing the native. It's kind of hard to explain, but I guess it's not at the same level of interaction with native code as Xamarin. And actually, something that's kind of interesting about Xamarin, and I know that we have like our Android area here. We can make some changes to that to change like the app name, the app icon, and all that kind of stuff. But with the nice thing with Xamarin and with Maui is that those when those access those items directly from the device, it's direct access. So it's accessing it via an API, whereas this compiles down, has an intermediate layer between, which I don't know. It's a horse apiece, as they might say out in the rural areas. It's entirely subjective. If you are just working on a create, read, update, delete app, kind of like we are here with an API, it doesn't really matter. But if you really want to get down into the nitty-gritty device, like accelerometer access, camera access, all the physical stuff of the device, you might be better off choosing Maui or Xamarin. I know that they have their. Some people love it, some people hate it, but and I mean, ideally, if you have the time, if you have the team, you would just have two teams, right? So you'd have a team for iOS development and a team for Android development. So one of them writes in the native language for iOS, and then the other one writes in the native language for Android. But that's not always possible. And if you think about what we're able to do here, which is create a mobile application that runs on both Android and iOS with just one code base, just one programmer writing all the logic. That's quite incredible. So again, it depends on the use case. A lot of the big companies, though, all of the, not all, but a lot of the really important applications, I don't want to name any because I don't want to be wrong, but just be aware that a lot of the bigger applications that people use every single day are probably written in their native language. So just something to keep in mind. Now that that tangent is over, let's continue here. After this list tile, we want to display some buttons. I'll set the alignment. So in here, now that we have this second area, let's just display a text widget. So as we can tell here, kind of how it's formatting each card. Just be mindful of that. Forming our UI here. So instead of displaying a text widget, we want to display a text button. This text button will take in a child of text widget. It says update. And then the on pressed, of course. Oh, okay. So just so that we can have this be green, let's add a little bit of quote-unquote logic. It's not going to be actual logic, but we'll be fooling the compiler into thinking that it is logic. So it'll show up as blue so that we can tap on it. Let's see here. There we go. So now we can tap on that. Next, we want a sized box. That's just to separate them. Width of 8 pixels. Another button. Sorry if you hear my dogs barking in the background. Ah, there he goes again. I'll pause if need be. Sorry about that. So, as I was saying, we're going to have another text button here. This one's going to say delete. And then we're going to have our on pressed. Let's see here. See what I'm missing here. Perfect. And there we go. That should be it. We could add another size box at the bottom, I suppose. There we go. That kind of wraps up the UI. So let's kind of go from start to finish again. So bad login, login failure, good login. We display all of our users and we can now do some stuff. Not actually, but we have the option to. So it got kind of long, hour and 20 minutes so far. But I hope this kind of demonstrates so far how we can use our access tokens later on in the application via the secure storage. There's like I said, there's other structures that you can use. There's other ways to handle it, but this one, as you can tell, works. And with the benefit, of course, just like any other good system, where we could access that token with any other call if we wish to add any other API calls. So it's coming along pretty nice. It's taking a little bit of time, but it's coming through. So if I hope you all liked the video. Thanks for watching.